Hello, I am Bernadette Devilat, architect and master in architecture from the Catholic University of Chile and PhD in architectural design from the Bartlett School of Architecture, University College London. Currently, I am the principal investigator of an AHRC DCMS funded research project 3D for Heritage India at Nottingham Trent University. Today, I will be presenting my work covering the active role of architectural and urban documentation. I want to show you a series of practice and research projects that have shaped my current interests in the role of three-layer scanning, drawing, and photography as documenting tools to record architectural and urban heritage at risk of disappearance due to disasters. From my PhD with case studies in Chile to the current projects in India, passing through a built house in Chile, my teaching experience at UCL, and exhibitions. The use of new technologies to record the built environment is increasing as they become affordable and more accessible than ever before. Among them, three-layer scanning is also known as LiDAR, can provide accurate documentation of the reality in the form of a measurable colored three-dimensional point cloud from which different outcomes can be generated. This technology is of particular relevance to seismic areas regularly affected by earthquakes, but can also be relevant to document other valuable buildings and places at risk of disappearance due to economic pressure and new developments. Not only is relevant as a digital archive, but also has the potential to inform architectural interventions based on the as-built condition of buildings using the millimetric data of the LiDAR record. Advanced recording technologies offer unprecedented capabilities for documented buildings regularly as a form of digital conservation. They are used for representation, heritage intervention, conservation, and post-earthquake assessment, museum collections, and many other applications. I have tried to use them in innovative ways to visualize the changes they have experienced throughout time, to question current intervention and reconstruction approaches, to develop a post-earthquake design methodology and risk mitigation, for situated and place-specific design, and to increase research impact, dissemination, and community engagement. In my PhD, I looked at the role of the record and reconstruction, exploring alternatives for heritage areas after earthquakes in Chile. Reconstruction is the ultimate type of intervention a building can experience, usually contested in the context of built heritage. The use of previous records and available remains is a way to settle debates around it. In the case of earthquakes, rebuilding processes follow periodically and are unquestioned due to the necessity to recover the dwelling space for the affected families. I use the case of Chile as a laboratory to study this issue, since earthquakes occur regularly. Even though changes in regulations have led to safer behavior of buildings in earthquakes, especially in urban areas, it is the built heritage that has been significantly affected. The pressure for quick reconstruction has led to a superficial understanding of heritage by offering solutions that look like the previous houses, but without considering other important aspects of their historical value, such as building techniques and human occupation. This raises the question of authenticity and also its impact in terms of the sustainability of the reconstruction, especially relevant when an accurate 3D record could be available. Beyond monumental heritage, which has been a widely addressed topic, the focus of my work is on housing in vernacular settlements as they conform a heritage set. In Chile, dwellings in heritage areas are characterized as sustainable answers to climate and environmental conditions using vernacular building techniques such as adobe and quincha. They are economically efficient in their use of resources, being physical support of their inhabitants' cultural expressions, such as religious festivities. One way to look at this is by using systematic recording and analyze buildings over time, and then try to have a different design approach for the reconstruction of these areas. Because earthquakes are common in Chile, regularly destroying built heritage, the idea of the record as an alternative to replacement and replica provides a rich field of inquiry. And how can this systematic recording be done using new technologies? Instead of recording for replication, meaning to physically rebuild as it was in case of destruction, as done by many, I use accurate 3D record as a way to question current reconstruction processes and develop an alternative vision to enhance the underlying values of vernacular constructions. I use the record as a method of analysis and as a tool for creating precise yet explorative interventions tailored to affected dwellings even when concerning complete heritage areas. As a methodology, in 2013, I surveyed 3 heritage areas in Chile, San Lorenzo de Tarapacá, Lolol, and Zúñiga, affected by different earthquakes, using 3D laser scanning complemented by photography and interviews. First, San Lorenzo de Tarapacá, affected by the 2005 earthquake, which was officially already reconstructed by 2013, yet with several buildings still in ruins. Diego Ramirez and I scanned these settlements in 3 days in 2013, resembling a post-earthquake emergency situation, with extra days for collecting social information. A terrestrial 3D laser scanner was used. No drones were available at the time, so no aerial information was captured. The data was used for videos, plans, sections, elevations with precision of millimeters, allowing to study seismic behavior, to propose alternatives to current reconstruction approaches, and study how buildings are used. Almost the whole village was obtained with some samples of interiors. A series of outcomes can be obtained from the data, such as technical drawings like architectural sections, plans and elevations, which can take the overall scale of the 3D data, in this case, the whole village. This allows producing architectural and technical drawings with precision of millimeters in a much safer way. The second village I scanned in my PhD is Zúñiga, affected by the 2010 earthquake, and it was waiting for its reconstruction, so it was captured in a state that was very similar to what it was possible to see right after the earthquake. This village was scanned in 3 days by 2 persons as well. Architectural plans of the houses that are part of Chilean historical areas are usually not available, either because they have not been designed using technical drawings or because they are too old to be found in archives. So most of the surveys had to be done after the earthquake. Following the 2010 earthquake, documents and plans, including as-built dimensions, were needed as a basis for any repair or reconstruction. Usually, dimensions are taken on site by hand and then transferred to a digital drawing, which tends to be a slow process, This work is habitually carried out by architectural students volunteering for that purpose. In this case, as it was a one-story dwelling, the accuracy of the measurements using both techniques do not differ radically. The key aspect is obtaining a large amount of measured and visual information in considerable less time. Moving into another house, the Galafe house at the bottom right, I tried another exercise to superimpose the 3-laser scanning and hand-measured drawing to compare and test limitations. The hand-measured survey does not identify the relevant distortions and cracks, but only the most damaged walls that require reconstruction. Heights and other measurements are also incorrect when compared to the 3-laser scan data. Also, one part of the dwelling has an angle of rotation in relation to the main facade, which was only captured in the 3-laser scanning survey. If you are interested, I published this exercise in a paper which reference you can see on the screen. The third village scanned as part of my PhD is Lolol, affected by the 2010 earthquake, which had an ongoing reconstruction process in 2013, with houses damaged, others under repair, and others already reconstructed. This is a plan view of the village obtained by sectioning the 3D point cloud. Again, almost the whole defined area with some samples of interiors, including the church. Some houses in ruins were captured by the 3-laser scanner before further decay in 2013. In this video, I explored the 3D point cloud of the village of Lolol, sectioned as in an architectural plan view, from the top. This measurable 3-dimensional model of the reality has precision of millimeters and served to create also technical drawings and images. It is composed of 195 independent scans taken over a period of 3 days on site by myself and one assistant, Felipe Lanuza. You can see here where the scanner was placed as indicated by the dark circles. The record captured houses that were already repaired as part of the government reconstruction program created after the 2010 earthquake, which you can see here. As such, this record of Lolol in 2013, with buildings damaged by the earthquake, others retrofitted, and others under reparation, is unique and represents an opportunity for further study and evaluation of those reconstruction processes carried out by the government. One of the things I am proposing in my PhD is to embed documentation in the forms I am showing here at an institutional level, and in that way to improve the reconstruction processes after earthquakes in Chile. For example, by using the 3-laser scan information, post-earthquake distortions can be identified to design specific supporting objects, depending on the level of damage, which can even be designed as permanent to increase seismic resistance. This could be wall supports that follow exactly the shape of the distorted surface according to the 3-laser scan, providing temporary structural support and safer passages for pedestrians. Also, to reuse and retrofit affected dwellings using the post-earthquake 3D record, resulting in the conservation of more houses instead of the complete replacement. I present more details on this paper, which focuses only on the immediate post-earthquake response, using the data for creating physical emergency supports and for the repair and strengthening of existing structures. However, in my thesis, I propose a more comprehensive methodology for a wider, long-term conservation strategy of housing in heritage areas that includes risk mitigation, planning, and post-earthquake response, which I named as reconstruction. And in that point of design, I will move to show you a project I did with my partner, Felipe Lanusa, at our practice. DLA Scan Architectural Studio. This was a commission we received to design a guest house in a rural plot of Talagante located near Santiago in Chile. We use 3-laser scanning as a form of a virtually situated practice. This 2-story guest house of 134 square meters is an example of remote design done from London, taking advantage of the accuracy and comprehensiveness of the 3D point cloud by inserting the proposal as closely as possible into the context. Thanks to this record, the new house was carefully positioned within the existing elements, and its geometry and vistas were determined in relation to their presence. And this is a view of the house inserted within the vegetation. So thanks to the data, we were able to carefully work with existing plants, flower beds, bushes, trees, pavings, and a pre-existing barbecue area in the corner of the site. This is the construction process and the finished house in 2018. Another interesting aspect of the 3D record is to document temporary events inside buildings, such as temporary exhibitions. This is the British Pavilion at the Venice Biennale in 2014. As part of my teaching at UCL of this form of recording, I have had the opportunity to document urban spaces in London, such as the area in Old Street, Gordon Square, and Canary Wharf. In the specific section on that teaching focused on historic environments, my teaching workshops with students included the St. Boniface Church in London, documented in more detail in that paper that you can see on the screen. One of the advantages of this record is that there is no fixed point of view. Everything can be defined afterwards, which is especially relevant for design purposes. Here are some more views. Another example of that same short course is the English Martyrs Church in London, with the 3-layer scanning that allows to place these buildings on their contexts, on their urban contexts. All these buildings are uploaded in this online database, the Bartlett 3Scan Library. And the visual quality of these records also have allowed me to develop a series of exhibitions. And here there is a point of representation I want to make. All methods of representation have aesthetic characteristics, but 3-layer scanning has a specific quality. Visualizations and videos have an aesthetic of immateriality, since the 3D data is composed of millions of points that give the perception of transparency. My attempt is to show the 3D scan data obtained in the best possible way, conveying fundamental viewpoints and selecting the most representative images, most of which are not possible to be obtained in reality, such as a section of a building, for example, but that are possible to be obtained by dissecting the 3D data. There is an element of dissemination, representation, and engagement with a wider audience through exhibitions. Here only a quick selection. In 2013, I explored the changes and the continuities that San Lorenzo de Tarapacá in Chile suffered since the 2005 earthquake by the juxtaposition of photographic records taken in different periods of time. In 2014, this exhibition showed different types of products from the 3-layer scan data in Chile, high-resolution images, 3D printed models of ruined houses in San Lorenzo de Tarapacá, and videos I created. In 2015, 2 large-scale images of Chile were displayed along an 18-meter-long hoarding in Gordon Street, UCL's entrance in London, after winning a competition. At the Seeing exhibition, exploring 3-layer scanning as a form of representation with this image and other videos. And finally, an artwork that is part of the permanent exhibition The Texture of Air at the new Royal National ENT and Eastman Dental Hospitals in London. The project attempted to capture the memory of the old buildings while still in use before the move, recording their spatial use and depicting activities using 3-layer scanning. Part of the data, such as this staircase, also informed a sculptural piece by other artists in the exhibition. This is the Royal National Throat, Nose and Ear Hospital, and a large section of it. These buildings were scanned again in collaboration with Bartlett students as teaching experiences. The artwork is a large combined section, looking at the interior spaces illuminated by the scanner. I would like to close this talk with a brief mention to my most recent projects in India, in which I continue to find new applications of the architectural record and its process. One project is surveying heritage buildings in Ahmedabad, India, empowering local action and skills for heritage conservation, funded internally by NTU with QR funds. This project aimed to install local capacities on surveying with these technologies, with workshops mixing on-site data collection in the historic city of Ahmedabad with remote sessions I delivered. During this training workshop, staff and students from SEPT University learned how to document buildings using 2 listed houses sitting within the World Heritage Site of Ahmedabad. Nonetheless, the scans were successfully combined into a 3-dimensional model with less than 5 mm of maximum error in only a couple of hours. This is the first one, House 361, and a ground floor plan obtained using the data from the workshop. And this is the first floor plan. This is the elevation of that house. And this is the second house, number 429, with ground floor in plan view. And the first floor. And the section. The second project derives from my previous PhD work I showed you at the beginning, developing a sustainable reconstruction method for seismic-prone areas of India based on advanced recording technologies. 3D for Heritage India for short. I am leading a great research team here at NTU with key partners in India, the Center for Heritage Conservation at SEPT Research and Development Foundation, also involved in the previous project, and the Hunarshalla Foundation. At a more international level, the team also includes ICROM. The focus is on housing in heritage areas of Gujarat, India, where damaged dwellings cannot be immediately repaired and retrofitted after earthquakes. One of the main challenges for that is to obtain the documentation of them. Due to COVID restrictions, we were not able to travel and carry out the data capture on-site by ourselves. So this was done by our project partners in India. They got expertise on laser scanning on-site through the parallel training project in Ahmedabad I just showed. During a week on-site, our project partners engaged with the community of Bela, the case study, while scanning the village, and carried out aerial drone documentation to complement the terrestrial laser data. This LiDAR record is providing a better basis for analysis and design. The 325 scans obtained were processed here in the UK by us, combining them. Here, this is a top view of one of the areas scanned, the fortress, and a zoom of that area. And the final result of the area captured in Bela. So now we are analyzing this information and crossing it with the social information obtained from the questionnaires and interviews. We are looking at each of the 18 buildings scanned interiorly and analyzing their condition, uses, and potential for being retrofitted, testing the method in this new context. We have 2 publications ready after presenting the work in conferences. One about my previous experience in Chile, and another one about the current project. We are working on a journal article and a guidance document on the use of laser scanning for post-earthquake documentation as well. To finish, just some concluding thoughts. Regarding Chile, I have demonstrated how 3D laser scanning can be an efficient and affordable post-earthquake documenting tool since almost the whole village was obtained in the 3 case studies with some samples of interiors, potentially informing and speeding up repair and reconstruction after earthquakes. Due to time, I focused only in one different aspect of the record in each case. First, recording seriously damaged buildings in a more safer way. Second, comparing 3-laser scanning with hand-measured surveys. And third, the potential of using the data as a basis for design. Regarding design, teaching and exhibiting, as any other representation, drawing from 3D scan data can be seen as a slice in a particular time. The aesthetics of rendering the point cloud also gives the impression of a fragile reality, which is especially interesting when applied to buildings at risk of disappearance. Regarding India, the reconstruction method under development in this project goes beyond the documentation. The record allows for an in-depth study of the material culture and ways of living of the domestic typologies presented, but only if combined with social, archival, and historical information. The LiDAR record is being a basis for analyzing, measuring, and visualizing vernacular architecture and its use for understanding earthquake-resistant traditional building techniques, enabling a culturally sensitive approach to the conservation and reconstruction of vernacular heritage. Thank you very much for your attention. I hope you can visit the website I have been showing, and please contact me if you have comments by email. Thank you.